Bohr's model of atom. Due to the drawbacks of Rutherford's model, Niels Bohr in 1913 proposed a new model of atom based on the quantum theory of radiation. Okay, based on quantum theory of radiation. Main postulates of this theory are: first point, electrons in an atom revolve around the nucleus in fixed circular paths called orbits. Electrons in an atom revolve around the nucleus in fixed circular paths called orbits. Okay. These orbits are associated with definite energies. That is, energies of all these circular paths are fixed. Okay, they are having definite energies, and these are called as energy levels. They are associated with definite energies. Okay, and these are called as energy levels or energy shells, or we can say stationary states, or allowed energy level or allowed stationary states. These are the different names of these orbits. Okay. Next, they are numbered as 1, 2, 3, etc. Numbered as 1, 2, 3, etc. and designated as K, L, M, N, etc. Okay. So the name of these different shells are K, L, M, N, etc. Okay. And important point is this 1, 2, 3 we are numbering from the nucleus. Okay. We have to start numbering from the nucleus. Second point. As long as the electron remains in a particular orbit, it does not gain or lose energy. Okay. As long as electron remains in a particular orbit or shell, okay, or energy level, it does not gain or lose energy. Okay, loss or gain energy. Okay, so the energy of that electron will be constant at a particular orbit. But when an electron absorbs certain energy, it moves from lower energy level to higher energy level. Okay, or it emits energy when it moves from higher energy level to the lower energy level. Okay, that is, energy change does not take place in a continuous manner. Okay, energy change does not take place in a continuous manner. That means does not takes place in a continuous manner. Okay, that means as long as no energy is absorbed or emit, the energy of that electron will remain constant. Okay, whenever it absorbs energy, it jumps from one lower energy level to higher energy level, or it emits energy when it moves back from higher energy level to the lower energy level. This is the second point. Now the third point. When an electron moving in a circular orbit has angular momentum, we know. Okay. When any small particle, here electron, when an electron moving around in a circular path, it possesses angular momentum, which is equal to, which it possesses angular momentum. Angular momentum will be equal to mvr. Angular momentum is mvr. M is the mass of the electron, v is the velocity of the electron, okay, and r is the radius of the orbit, okay. M is the mass, v velocity, and r is the radius of the orbit, okay. The important point here is only those orbits are permitted or allowed in a circular path in which the angular momentum of the electron is a whole number multiple of h by 2 pi. Okay, so those orbits are only permitted or allowed only if the angular momentum of the electron will be equal to the whole number multiple of h by 2 pi. Okay, that is only those orbits are permitted or allowed only if the angular momentum is equal to the angular momentum equals the whole number multiple of nh by 2 pi. Whole number multiple of h by 2 pi. That means we can say mvr is equal to integral, that is whole number multiple. So n into h by 2 pi, where n will be 1, 2, 3, etc. Whole numbers. Okay. So angular momentum is equal to the whole number multiple of h by 2 pi. This is the third point. Okay. Fourth point. Energy is emitted or absorbed by an atom when an electron moves between two energy states. Okay, that is fourth one. Energy is emitted or absorbed by an atom when an electron moves from one energy level to another energy level or between two energy levels. Okay, from one energy level to another level. Okay. Okay, and the energy emitted or absorbed, the amount of energy emitted or absorbed will be equal to the energy difference between these two energy levels. Okay, let E2 and E1 are the energies of higher level and lower level. Higher and lower levels. Okay. Then delta E is the difference between them. And this energy, this delta E is the amount of energy emitted or absorbed by the atom. Okay. And we know delta E will be equal to E2 minus E1. Or we can say is equal to h nu. So from this nu, the frequency of the radiation we can calculate, that is equal to delta E by h, or this is equal to E2 minus E1. So nu, the frequency of the radiation will be equal to the difference between the two levels, that is higher energy level and the lower energy level, divided by the Planck's constant. H is Planck's constant. Okay. And this equation is known as Bohr's frequency rule. Okay. These are the different postulates of Bohr's model. Okay.